Hello everyone. Today we are going to discuss about the topic of encryption and network security in respect of e-commerce environment. In the previous video we have discussed about various security threats in e-commerce environment, and today we are going to discuss about the encryption. So first, before going in the details of encryption, first we would like to understand some basic terms that are used in encryption. The first one is cryptology. The cryptology is actually the branch of mathematics which is the combination of cryptography and cryptanalysis and also steganography. That is, the cryptology is divided into three parts: cryptography, cryptanalysis, and steganography. The encryption that we are discussing about comes under the cryptography. So the cryptography is the science of coding and decoding messages so as to keep these messages secure. That means in cryptography we change the message in such a format that is not understandable by the unauthorized users. Those are known as attackers or hackers. If they penetrate through the network and they access your message, then the message is totally in an ununderstandable format. If the attacker accesses the message, still he is not able to understand what the message conveys. And it is done using a secret key that is called encryption key at the sender side, and at the receiver side reverse process is done using the same or the different key to obtain the actual message. Then comes cryptanalysis. Cryptanalysis is the part of the encryption scheme which deals with the analysis of various algorithms and procedures that are used for encryption and for protection of your data or messages and the information over the network. Then comes cryptosystem. Cryptosystem is basically a complete system from the sender to the receiver and in between process. That means from converting the original message into an ununderstandable format to the conversion of ununderstandable message into the actual message at the receiver end. The complete process is cryptosystem. Then comes steganography. Steganography is the science of hiding the information. That means it is that process through which we hide the information from the unauthorized or unintentional users so as to protect the information from being used for malicious activities. So now we are talking about the encryption techniques for data and message security. That means information security. And for that we are having the two major techniques of encryption, that is private key cryptography and public key cryptography. In cryptography, basically what we does, we provide the actual message to the encryption scheme, and the encryption scheme uses a particular key, and that key is used to encrypt the message into an understandable format, and this ununderstandable format message is sent over the network for protection so that the unauthorized users can access the message but cannot understand it. And then at the receiving end, a reverse process is done, that is conversion of ununderstandable message into the actual message using the same encryption key that is used at the sender side or the different key from that used at the sender side, and the actual message is obtained. That is actually the concept of cryptography. If we talk about cryptography and its applications, then it is used almost everywhere. For example, in secure communication, web traffic, that is HTTPS, Hypertext Transfer Protocol with security. And then this security is basically the various certificates and algorithms used for protection of the data during transmission. In wireless traffics, that is in Wi-Fi's and in hotspot areas, in GSM global system for mobile communication and for Bluetooth connectivity, in encrypting the files on the disks in the hard disks, in the content protection, that is in DVDs or Blu-rays, CSS, AACs, these are the formats. Then user authentication, to provide the valid user authentication that who is accessing the system or the information from the device, and many more applications that are being implemented with the uses of encryption or cryptography. This is the history of cryptography, that is in 1900 BC, where it was first found to be used in an inscription carved in the main chamber of the tomb of the nobleman Khnumhotep II in Egypt. Around 400 BC, the Spartans used a system of encrypting information by writing a message on a sheet of papers. Around 100 BC, Julius Caesar was known to use a form of encryption to convey secret messages to his army generals posted in the war front. During the 16th century, Wigner designed a cipher that was supposed the first cipher which used an encryption key. At the start of the 19th century, when everything became electric, everything is over the web, Haburn designed an electromechanical contraption which was called the Haburn rotor machine for producing the encrypted message. And these are the ciphers. In cryptography, a cipher is an algorithm for performing encryption or decryption. That is the actual method, the process that we are using to encrypt the actual message into an ununderstandable format. That algorithm is known as the cipher. It is a series of well-defined steps that can be followed as a procedure. That means it uses a particular process through which we convert the actual message into an understandable format. An alternative less common term is encipherment. That means cipher is also known as encipherment. Encryption. Encryption is a basic term that refers to the act of encoding data in this context so that those data can be securely transmitted over the internet. That means it is the process through which we convert the actual data into an ununderstandable format, and that data in unreadable format is sent over the network so that if it is being accessed by an unauthorized user, still it is protected, it is secure because it is ununderstandable. So basic advantages of encryption, if we talk about, the first one is establishing the identity of users. That means it establishes the identity of the authorized users that can have access to the particular information. It also controls the unauthorized transmission or forwarding of the data. It also verifies the integrity of the data, that the data that is actually sent from the sender is received by the receiver. That means alteration of the message is not done over the network. It also ensures that users take responsibility for data that they have sent this particular data. That means non-repudiation. If you have sent some particular data, so you must accept that you have sent this. For that, encryption also works. So basically, encryption therefore used to keep communications secret or to identify people involved in communication, that who are the peoples who are actually interacting in the communication process. So it provides the security in basically four major categories. The first one is message integrity. Message integrity provides assurance that the message has not been altered. Second one is non-repudiation, which prevents the users from denying that he or she has sent the data. That means you can't deny if you have sent a data to a particular user. Then authentication. Authentication is the verification process of a particular person's identity over the machine who is actually communicating with the device. The last one is the confidentiality. Confidentiality is the assurance of the message or the information that it has not been accessed or read by any unauthorized users. And there are basically two types of encryption, that is symmetric key encryption and asymmetric key encryption. Symmetric key and asymmetric encryptions are used often to provide a variety of security functions for data and message security. As we already discussed, symmetric key encryption is also known as private key encryption, and asymmetric key is also known as public key encryption, as symmetric key uses only a single key for encryption and decryption, the reverse of encryption. And in asymmetric key, two keys are used, one at the sender side and the another key is used at the receiver side for the decryption. So cryptosystems and cryptography methods. The cryptosystem, as we have already discussed, it is a suite of cryptographic algorithms needed to implement a particular security service, most commonly for achieving confidentiality encryption. Typically, a crypto system consists of three algorithms, one for key generation, one for encryption, and one for decryption. That is the complete process of encrypting a message from end to end. That means first you have to generate a key, then you have to use that key for encrypting the message. Then at the receiver end, you have to use the key to decrypt the message back into the original message. And for that, two algorithms, as we have already stated, symmetric key cryptography and asymmetric key cryptography. Symmetric key cryptography uses same key for encryption and decryption. Make it very clear, encryption is done at the sender end and it is the process of converting original message into ciphertext. That means encrypted message. And decryption is done at the receiving end. It is the reverse of encryption and it is the process of converting the encrypted message into the original message that was sent by the sender. In this, the problem arises of the distribution of key. As there is a single key, the sender, after encrypting the message, has to send that key to the receiver so that the receiver can use the same key to decrypt the message. If the key is not there with the receiver, then the receiver cannot decrypt the message into the original form. Second one is asymmetric key cryptography. In this, there is a pair of keys used for the complete process. One key is used at the sender's end, that is for encryption, and the other key will be used at the receiving end, that is for decryption process. The two keys are termed as, one is the public key and the other one is the private key. This is the symmetric cryptosystem, in which it is also called a secret key cryptography, as single key is used for both encryption and decryption, and it is the secret key that is only available with the sender and the receiver of the message. And this is the also the primary condition of the algorithm that the key must be known to both the parties. If both the parties know, then only the encryption and decryption processes can be done. So as you can see in the diagram, we are feeding a plain text to the encryption mechanism. This encryption mechanism uses a key. This key is used to convert the plain text into the cipher text. This is the cipher text which is in an understandable format, and this cipher text will be sent over the network. At the receiving end, reverse process decryption is done, and decryption is done using the same key that was used for encryption. It is sent over the different network to the receiver, and that network is specifically a secure network, so that the key must not be uh, accessed by any unauthorized user. In the decryption, the receiving end uses the same key to decrypt the message and convert the encrypted cipher text into the original plain text that was actually sent by the user. This is the complete scenario of symmetric key cryptosystem. This is all the details that we have discussed about symmetric key encryption. That is, it uses the same key for encrypting and decrypting. It is also called secret key. It is as it is kept as a secret shared key between the sender and the receiver. This is the another example that is shown for encryption and decryption using the private key encryption, in which plain text gets converted into ciphertext at the sender end using the encryption algorithm that uses a shared secret key, and at the receiving end that ciphertext gets converted back into the plain text using the encryption algorithm using same secret key, and the process is called decryption. Then second one is the public key cryptosystem or asymmetric key cryptosystem. It uses a pair of keys, as we have already said. One is the public key, which is used for encryption of the data, and then is corresponding private key or secret key that is used at the receiving end for decryption of data from ciphertext to the plain text. As you can see in the diagram, Alice is the sender and Bob is the receiver. Alice sends a plain text, and that plain text is fed into the encryption algorithm. That encryption algorithm uses the public key of Bob, public key of the receiver, and using the public key of receiver, Alice performs the encryption mechanism. As you can see, name is public key. The public key is available to everyone over the network. That means it is shared among all over the network by the every user on the network, and using that public key of a particular user, message is encrypted and sent over the network in form of ciphertext. At the receiving end, decryption is done by the receiver. That is, Bob is the receiver, and it uses its private key to decrypt the message and obtains the plain text. Now make it very clear that public keys is available to everyone over the network, but private key is available only with the Bob, that can be used to decrypt the message. Since no one else on the network has the private key of the Bob, so no one can obtain the plain text from the actual message, from the encrypted message. So the data will be protected here. This is all the details about the encryption that we have discussed. This is the another scenario where Alice wants to send a message using the Bob's public key, and the Bob converts the message using the Bob's private key. Bob is the receiver whose public key is used for encryption, and Bob itself uses the private key to decrypt the message. This whole scenario is shown. Alice gets the public key of Bob and encrypts his message. Then Alice sends the encrypted message over the web. Then Bob's public key is available over the web, as you know. Then Bob's private key is used, and the actual message is obtained by the Bob. This is the complete scenario that is shown. Simply, we can say about the asymmetric key algorithm or the public key crypto system that private keys are used for decrypting and public keys are used for encrypting. Plain text gets converted into ciphertext using public key, and ciphertext gets converted into plain text using private key of the receiver. So basically, these are the functions that are performed by the public key encryption, that is to encrypt the encrypt symmetric secret keys to protect the symmetric keys during exchange over the network. Create digital signatures to provide authentication and non-repudiation for online entities. And to create digital signatures to provide data integrity for electronic files and documents. Algorithms that use public key encryption methods include RSA and Bellman-Hellman. Bell-Hellman. These are the common types of cryptographic attacks that happens over the network. That is brute force attacks. Brute force attack are those kind of attacks in which attackers are trying to access all keys in the key space. That means attackers try to access the secret keys, encryption keys that are available over the network. Another is chosen ciphertext, that is the decryption of the ciphertext to decrypt to discover the key. That means the attacker tries to decrypt the ciphertext using various keys. That means hit and trial methods it uses, and if some particular key works on the message to obtain the actual message, then that key is known to the attacker, and he or she can use that key whenever the communication arises from that particular user. Then another one is the dictionary attack. That means find plain text based on common words. That means it uses the common sense technique of the brain, that uh, plain text is obtained on the basis of the common words that are used during the communication process. That means attacker uh, keeps the track or the statistics of the communication between the users, communicating users, and then finds out a particular pattern on the basis of which the plain text is obtained by the attacker. And last one is the frequency analysis. That means guessing the values based on frequency of occurrence. That means for what number of times the particular message or information is uh, happening or occurring in the network. According to that, the attacker tries to find out the values according to frequency and then tries to obtain the actual message from the ciphertext. So this is all about encryption. Thank you very much.